Hey guys, Mr. Gibson here. I'm going to show you guys a macroeconomic FRQ. We'll ignore the parts of the questions that have to do with the units that we're not going to cover on the AP exam, which are the open economy stuff, the exchange rate stuff. Okay, so anyway, it says Canada is an open economy. Again, we won't have to deal with that. That is currently in a recessionary output gap. Okay, the first question is about a drawing the ASAD curve for all this. And I'm going to do that again. You guys won't have to do this on the test, but they're going to have to ask you guys questions about graphs. Okay. So it's going to be helpful to be able to sketch a graph and, of course, understand what the graphs are doing. Okay. So we want the full employment out level. There we go. Which is represented by the long run aggregate supply curve. Okay. Let me just fix this real quick. Okay. All right. And we're in a recessionary gap, so we're going to be to the left of this. So this is P sub F for the full employment level. Y sub F, excuse me. Y1 and PL sub 1. Okay. So Central Bank and the government do not take any policy actions to close the output gap. Explain how the economy will adjust to full employment in the long run. On your graph, show how the economy adjusts to full employment in the long run. Okay, so again, you won't have to draw this. I won't write all this down just because for the sake of time. But what happens is this: is the if recessionary gap, the short run aggregate supply curve is going to shift to the right. Okay, and that's because of nominal wages. Okay. Nominal wages are going to decrease. Okay. And as nominal wages decrease, the short run aggregate supply curve increases, shifting to the right. Okay. It's probably a good enough explanation. Some more kind of conceptual background to this. If there's high unemployment, then people will be willing to work for less money, which will drive wages down. Also, there's deflationary pressure. So if people are experiencing deflation, then they can have the same quality life at a lower wage. Okay. So that should explain most of what's going on here. Okay. Let's go to C. And we're going to have a multiplier problem here because it says suppose the Canadian government is unwilling to wait for the long run adjustment process. The marginal propensity to consume is 0.8. The equilibrium real output is $500 billion, and the full employment output is $540 billion. Calculate the minimum change and indicate the direction of the change in government spending required to shift the aggregate demand curve by the amount of the outcome gap. And then it asks, calculate the minimum change to indicate the direction of change in taxes required to shift the aggregate demand curve by the amount of the output gap. So the output gap, so our output is $500 billion right now. Full employment is $540 billion. So we want to make up this $40 billion gap. Okay. So let's talk about how to do that. All right. Okay. So what happens here? So what happens here is this. Sorry. I thought I expanded my view a little bit. What is going on? All right, real quickly here. Oh, it's because I was way down here. Okay. Sorry, you guys. Let me come on back up so we can have a little bit more room. All right. So this is a question about that multiplier effect. Okay. And what multiplier effect is you'll have an initial amount times the multiplier will equal the total. Okay. All right. The multiplier is 1 minus 1 over MP, 1 over 1 minus MPC. I gave you guys a recap video of this if you guys are curious about where I'm getting this stuff from. In this case, the MPC is 0.8. So 1 minus 0.8 is 0.2. That's also the marginal propensity to save. Okay. 0.2 is 1/5. 1 over 1/5 equals 5. And so that means our multiplier is 5. Okay. The thing that makes this a little different is we're not going to start with an initial amount and find a total. We start with a total of 40 billion and we want to find an initial amount. So in this case, all I got to do is divide by 5. That's 8. So we want a $8 billion increase in government spending. Okay, because an increase in government spending will increase the aggregate demand, the multiplier effect. If you increase the uh, if you increase the government spending by $8 billion, multiplier effect will have a $40 billion effect on the economy. Okay. Now the taxes. Now taxes are a little different. Okay, because see the good thing about a government spending, if you guys would watch that other video, is government spending uh, starts that initial spending is spent within the economy. Taxes, there's this initial spending that doesn't happen because um, people will save some of their cash. Okay, so if you need some more information about that, I do encourage you guys to watch that video about MPC. Okay, so uh, here's our initial amount, and our initial amount is going to be affected first by the marginal propensity to consume. So this is the initial amount times the marginal propensity to consume. So this is the initial amount that's going to be consumed first. Okay. And then we have the good old multiplier effect to that. And that's going to equal the total. Okay. So that's how this is going to work for taxes. All right. Okay. So let's do some real quick math here. MPC, as we already said, was 0.8. Okay. Or that's better yet, 4/5. Again, on this, you'll get to use a calculator on this test, which will be kind of nice for you guys. The multiplier, why am I even doing the extra math here? We already know the multiplier is 5. So that's 5 over 1. These 5s cancel. Okay. So I'm left with I, and this tax multiplier, that's what we end up calling this, and the tax multiplier is a 4. Okay. And we want the total to be 40 billion. Divide by 4. Okay. And I get I equals $10 billion. Okay. So we will need a $10 billion decrease in taxes. Okay. A $10 billion tax cut, because again, you need to cut taxes or decrease taxes to spur consumer spending that have $10 billion. Okay. So this will have to come in a decrease in taxes. So you'd actually say a negative $10 billion. Okay. Keep that in mind. All right. D, doing some financial market stuff here. Assume instead that the Canadian Central Bank takes actions to restore the economy to full employment output by influencing investment spending. Draw a correctly labeled graph of the money market and show the effective actions shown taken by the central bank on the equilibrium interest rate. Okay, so again, you won't have to, this is a pure graphing problem, and you won't have to do that, but we're going to go through it anyway, just to remember stuff about the money market. Okay, so the money market looks like this. There's some quantity of money. There's a nominal interest rate. There's money supply, which is controlled by the Fed. And there's a money demand that's downward sloping. Okay, so what the Fed does, or any central bank, in this case, the Canadian Central Bank, they're going to increase the money supply, which decreases the interest rate. Okay, and the decreased interest rate makes the rental of capital less, the rental of money less, makes it cheaper to borrow, in other words. And because it's cheaper to borrow, interest sensitive spending, which is typically investment spending, spending on capital, goes up. And if investment spending goes up, AD increases, which of course means output increases as well. All right, in the short run. So here's your money market graph, and here's the basic idea of, the Fed increases the money supply to decrease the interest rate, to spur the economy, to stimulate the economy. Okay, increase the AD. E, trading partners, foreign exchange market, don't have to worry about it. Okay, so we're done with number one. All right. Assume the expected inflation rate in a country is 3% and the current unemployment rate is 6% and the natural rate of unemployment is 4%. Okay. Pardon me. So this is a Phillips curve problem. Again, it's going to tell us to draw the Phillips curve. You guys won't have to do that, but might as well do it anyway just to see how it works. Okay, draw the short run and long run Phillips curve. Label the short run equilibrium as point X and plot the numerical values on the graph. So then we're going to answer some questions about it. Okay, so let's just start with drawing it first and understanding it, and then we'll jump to the questions real quickly. Okay, so Phillips curve is set up like this. Okay, you've got unemployment and you've got inflation. Okay, it shows the trade-off between inflation and unemployment. In the short run, there is a trade-off. Okay. If you've got a high unemployment rate, you'll have a low inflation rate, versus if you have a high inflation rate, you'll have a low unemployment rate. Okay, basic idea there. You will also, but in the long run, inflation doesn't matter. Prices, everything adjusts to the price expectations. And we're at this long run Phillips curve right here. Okay. So back to our thing here. It says expected unemployment in a country is 3%. The current unemployment rate is 6%. And the natural unemployment rate is 4%. Okay. So that means we're right for the long run Phillips curve. That's our natural rate of unemployment. It's going to be right here at 4%. We're in a situation over here where we have higher unemployment. Okay, we're in a recession. Okay, so we have 6% unemployment. And our inflation rate is 3%. Hold up. I'm not quite sure if that's right real quick. I think there's a little trick to this one, you guys. Let me hold off on drawing this. Hold up. It said expected inflation rate is 3%. Current unemployment rate and the natural rate. Okay. So if the expected unemployment rate or expected inflation rate was 3%, that means people adjusted their expectations to a 3% inflation rate. So the expected inflation rate is going to be right here where the short run and the long run Phillips curve meet each other. Okay. So if inflation actually ends up being 3%, we would have had 4% unemployment. So something happened in the economy that caused this inflation not to be as high. Okay. So is the actual inflation rate greater than, less than, or equal to the expected inflation rate of 3%? Well, we can look from the graph, and this is why it's important to draw a graph. Well, the expected unemployment or expected inflation rate was 3%. And if that was the case, we'd have our regular employment, our full employment of 4%. But instead, we have this recessionary gap where we have 6% unemployment. And if you can look at the graph, well, that means that we have some sort of deflation going on. The inflation rate dropped. So our expected inflation rate was 3%, but our actual uh, inflation rate was less than that. Okay, so we ended up with some unemployment. Okay, so that's where it's going to be less than. Assume loans were made taking into account expected inflation of 3%. Will lenders be better off or worse off after they realize the actual inflation rate identified in part B? Explain. Okay, so we'll talk about this conceptually, but we'll also look at it mathematically. Okay, your real return is the nominal interest rate minus inflation. Okay. So let's say we wanted a real return of 10%, and we know inflation is going to be 3%. All right. So we say, well, we're going to have to give a nominal interest rate of 13% to get that return, 10%. But what happens if the inflation instead is 2%? Well, the real return instead is 11%. So that helps lenders. Okay. That helps lenders. They expected higher inflation, adjusted their inflation rates to that higher inflation. Inflation went lower. So the real return that they get on that is higher. Okay. So these higher interest rates will actually have higher returns. Okay. All right. Based on the relationship between the actual and expected inflation rates identified in Part A, what will happen to the natural rate of unemployment in the long run? Absolutely nothing. Absolutely nothing. Okay. Um, the oh, excuse me. I confused myself. Nothing will happen to that. What will happen to the natural rate of unemployment in the long run? Nothing will happen to the natural rate of unemployment in the long run. It always stays the same. Okay, confused myself for a second there. Okay, all right. Number 3, real quick. Assume households in econ land increase their savings for retirement. Using a correctly labeled graph of loadable funds market, show how an increase in savings will affect the equilibrium interest rate. And then B and C have to do with other with international trade and all that good stuff. So we're going to ignore that. Okay. Let me erase this real quick. Okay. So, real quick, this is good because we can look at a loanable funds market, amount of loanable funds, real interest rate. We've got our demand for loanable funds, which is investment spending usually. And then S is the supply of loanable funds, which is the savings. So more people are saving for retirement. That means we've increased the amount that we're saving. And if we increase the amount that we're saving, that means the real interest rate is going to fall. Okay, so national savings went up because of these more personal savings, and that means the real interest rate fell. Okay, and that's it with that one. Let's go through some scoring guidelines real quick. All right. All right, you guys can find these online if you need to. Here's your recessionary gap with our ASAD curves. Okay. 1 point is earned for explaining that nominal wages, input prices, or expected inflation will decrease causing the short run aggregate supply curve to shift to the right. Okay, reach back to that full employment level. $8 billion in government spending versus $10 billion in a decrease in taxes or tax cut. Okay, there's our graph for the money market. There's the central bank increasing the money supply for a lower nominal interest rate. E we didn't do. Short run Phillips curve. Long run Phillips curve with our expected inflation is where the long run Phillips curve meets the short run Phillips curve. And of course, the long run Phillips curve is also the natural rate of unemployment. And this shows that we are in a place to the right of the long run, the full employment level with a higher unemployment rate, a recessionary gap. One point is stating that the actual employment rate is less than the expected inflation rate. One point is earned, stating that lenders will be better off, and for explaining that real value of loans will be repaid will be higher than expected, or explaining that the relationship between the nominal and the real interest rates using the Fisher equation. We use the Fisher equation. That's the equation that we showed. Okay. One point is earned for saying the natural rate of unemployment will not change. Okay. That was like a trick question right there. All right. Here's our loanable funds market. And here's the rightward shift of the supply in the loanable funds market and showing that the equilibrium real interest rate will fall. Okay. So thanks for your attention.